Welcome to FMA0146 Basic Mathematics. In this video, we are going to discuss Chapter 4, Matrices and System of Linear Equations. In Chapter 4.1, Matrices, we are going to discuss type of matrices, operation on matrices, and the properties of the matrices. Okay, so the term that we use in the matrix, for example, you have a name for that matrix is A, and then over here, on the leg of our A, we have the m times n. Over here actually means that the size of our A, or we can call it as the order. Okay, and the first element, okay, is indicating the numbers of the rows, and the second one is indicating the numbers of the column. Okay, so means, and then each of the input inside our matrices, we call it as element, and over here we if our matrix we use the capital A, so normally the one element we use a small letter A. And we also using the same way of numbering it. The I over here is stand for the row, and then the J is standing for the number of the column. So for example, let's say we look at our H. Okay, so our H, the size is 1 times, okay, only one row, and we have a 3 column, and the element of the first row and the second column is called H12 is 2, or we have an H13 equals to 0. For example, this one E33 actually is the small letter, E33 is 3. Okay, so then that is our how you numbering our element. And then the row is just now, as I said, this is called row, and then this one is called column, and the size is what is the order of our matrix. Then over here, if our G actually is size of 3 times 1, and H is 1 times 3, and our E is 3 times 3. And then we have few types of the name for our matrices. The first one is called square matrix. Okay, square matrix, or sometimes we just name it as an n multiple n. The number must be the same since it is a square. So for example, the smallest actually is 2 times 2, 3 times 3, 4 times 4. This is all our matrices. Over here, F, B, C, E, D, and our A are all is the square matrix. Zero matrix means that is all the element inside our matrix is the all the element must be 0. So over here, if you see that if they only have one, actually is our B. Okay, is the zero matrix. Diagonal matrix means that you look at the diagonal. Okay, this is called the diagonal. Okay, only the square matrix has the diagonal. Okay, if you see this one, you cannot form a diagonal, so this one don't have a diagonal. This one also doesn't have the diagonal, and then this is my diagonal, and this one is my diagonal. Diagonal means that is only the value on the diagonal we have the value. Means this is not 0. Means that any element of the diagonal is 0. So for example, the D, this is my diagonal, and then anything outside of our diagonal is 0. So this one is called our diagonal matrix. And then our A also a diagonal. And although C, there is a chances this is a diagonal, but unfortunately this one is 1, so this one is not a diagonal matrix. And then the E definitely is not, and then our F is a diagonal. Okay, this one yes, and then this one yes. Oh, sorry, this one and this one is no. Okay, the D, so our A, D, E, F is diagonal, and our B is not diagonal since on the diagonal itself also 0, so actually it's only is a 0 matrix. Okay, identity means that it must be a diagonal matrix. All the elements on the diagonal must be all 1. Okay, so just now we have our F, E, C, D, and A are diagonal matrix, but only A and F, the diagonal input is 1, so they are identity matrix, and F is the identity matrix, is I2, means is for the size of 2, and then A is this identity for the size of 3. Okay, 3 by 3. Row matrix means is I only have one row, so for example is our H, and the column matrix means I only have one column, is our G. Okay, upper triangular matrix. What is called upper triangle matrix is we look at the diagonal. Okay, we only, so that means H and G definitely is not our, it will never be our upper triangular matrix because they don't have a diagonal. So that's mean upper triangular matrix must be a square matrix. Okay, and then what we do is we look at our diagonal. Okay, only the upper part of our diagonal has the element. Okay, means that it's not 0. So for example is E. Okay, this is my diagonal, and on top of my upper part of my diagonal there is an element -2, which is not 0, -2 and 5. So E is my upper triangular. Okay, identity is not a upper triangular because the top is 0. Okay, this one also not. Okay, and then this one is not. Okay, now, and then lower means that is I have my diagonal and the lower part is not 0, so there is a 1 here, so that is my C. Okay, equal matrix. What is equal matrix? Means that I have two matrices, A and B. When I say A is equals to B, first thing, they must be same size. And then the second one is every element inside my matrix must be the same. So for example, if I have A, B, C, D, so for my A, then let's say my B is 1, 2, 3, 4. So my A must be 1, my B equals to must be 2, my C must be 3, and my D must be 4. Then this is called equal matrix, where first thing, the size must be the same, and then the second one is every element must have the same value. Okay, so now we look at our operation on matrices. If you notice here, we have one. The first one is plus, minus, scalar multiply, and then we have a multiplication. And then if you notice, we don't have the divide. Okay, so if you want to plus or minus any two matrices, okay, so it means that the first for this one, plus minus, they are the same. First thing, they must be the same size. If let's say I have my G, okay, if I have my G is G is the size 3 times 1, so I must only choose the partner with 3 times 1, so that means is my H. I cannot choose others to sum or to subtract, means that I only have G plus H, or you can say that H minus G, doesn't matter, they must be the same size. Okay, so means that my E only can plus D only over here, or my D can only minus E. So they can only play together with the people with the same size of the matrix. Okay, so how do you want to sum or minus the matrix? We only plus or minus the same location. Okay, so for example, if I want to have G plus H, my G is -1, 0, 5, and then I want to plus my H is 1, 0, -1. So the first element play with the first element, so means is -1 plus 1. And then the second one is 0 plus 0. And then the third one is 5 minus 1. Only the same, they play together with the same location. So I have 0, 0, 4. Okay, if you want, let's say this one, I want to have a H minus G. So what is my H? 1, 0, -1. Okay, minus G, my G is -1, 0, 5. So only the same location, 1 plus 1, 0 minus 0, minus 1 minus 5. So finally, I have a 2, 0, -6. Okay, so how about the 3 by 3? They are the same, regardless whatever, as long as you only can plus or minus the same location. So my my E, is actually this one is E. E plus D, so my E is 100, 100, 0, 020, -253. So I want to plus with my D is 100, 020, 003. Same location, so definitely I'm going to have 9 of them. Same location is 1 plus 1. And then 0 plus 0 is 0. -2 plus 0. And then 0 plus 0, 2 plus 2. And then 5 plus 0. And then here 0 plus 0. And then 0 plus 0, 3 plus 3. Okay, and then you use, you calculate. So for the plus minus must be the same size, and you sum or subtract the element at exactly the same location. Okay, so now we look at our scalar multiply or scalar product. Means that we are going to multiply our matrix with a scalar or a number. Okay, or we can call it as an constant. So for example, I want to multiply 2 with my matrix J, or we can just write as a 2J. So means that I'm going to use 2 multiply 1, 2, 0. And remember, every element receive the 2 together. So that means you're going to have a 2, 4, 0. 2 multiply is 2, 2 multiply 2 is 4, 2 multiply 0 is 0. So scalar multiplication is every element receive the same thing. So if you want to do -3e, means I have multiplied this one is -3, then 0, 6, 0, -6, -15, 0, 0, and 3 multiple -3, so -9. So then that is called as a scalar multiplication. Okay, so now after the metric scalar multiplication, we look at our multiplication of 2 different matrices. Okay, now over here we have one rules for the multiplication of 2 different matrices A and B. If you want to multiply these 2 matrices, the first thing, let's say my A is of the size m times n, and my B is the size of P times Q. And the only rules that is the value of these 2, okay, the column of my A and the row of my B must be equal. And my n equals to P. So means that, let's say my A is 3 times 3. If I want to have a multiplication with another matrix with a B, they must start with the size of the row 3. It's regardless it's 3 times 1, doesn't matter, or 3 times 2, 3 times 3, even can 3 times 4, as long as the column and the row, these 2 value must be the same. And the output of the matrix of this product is, let's say we name it as C, and the size is, we take the row is M, and the column of the second matrix. So this one, let's say I have a 3 times 3 multiplied 3 times 1. Let's say I have a 3 times 2. So my output actually is C 3 times 2. Okay, so, or if you see that is it, if I change this one, so I will have a 2 times 3 times 3 times 2, actually is 2 times 2. Okay, so then that is how you want to get the, first thing, how to get the multiplication of two matrices correct. Okay, after that, how you want to, excuse me, how do you want to multiply two matrices of, doesn't matter what is the size, as long as the column and the row must be equal. Okay, now let's say I take over here. Okay, so I use G times J. What is my G? G, okay, my G actually is 3 times 1, and my J is 1 times 3. So this one are equal. So my expectation, let's say, is a P, my matrix P will be 3 times 3. Okay, so how we going to multiply? Negative 1, 0, 5, and then multiply with 1, 2, 0. Okay, so let's say, how do you want? Okay, we go by row. Okay, we go, the first one, we go this way, go right hand side, going to right hand side, and for the second one, we going down. Okay, so I think the easiest one to see, okay, the multiplication actually is by using 3 times 3. Okay, that is the easiest way that you to see how the multiplication working. 3 times 3 multiply our D 3 times 3. Let's say I will get an L 3 times 3. Okay, so let's say my E is 100, 0 to 0, negative 2, 5, 3, multiply with 100, okay, and 2, 0, 0, 3. Okay, now, how to multiply? Okay, so what you're going to do is, you are taking this one, first row, and the second row, and multiply the column, okay, element with element. So means that 1 multiplied 1, okay, 1 multiplied 1 is 1, plus 0 multiplied 0 is 0, negative 2 multiplied 0 is 0. Okay, after that, what you're going to do next? Let's say if you're going to move to the second element, the first row, second column. So what you're going to look at actually is the same thing, is the first row, okay, but now you are looking at the second column. So same thing, the first multiplied with 0, 0, 0 multiplied with 2 is 0, 2 multiplied with 0 is 0, and then the last one actually is first row, third column, 1 multiplied 0, 0 multiplied 0, 3 multiplied 2 actually is 6. And in between them is a plus. Okay, so let us try another one element here. That is, let's say, I want to know the element here. So actually is the third row, okay, and the third column. 0 multiplied 0 plus 0 multiplied 0 plus 3 multiplied 3 actually is 9. So you are going to do all of them like that. Okay, so this is how you want to do the multiplication of two matrices. The first one we go by the row, and then for the second matrix we go by the column. Okay, now we have few properties of our matrices. If you have the matrix A plus B, actually is same as a matrix B plus A, so it's interchangeable. But the thing is, if you have matrix A minus B, is not B minus A. It's just like that you have a number. 2 minus 3 will not be same as 3 minus 2. So it's applied to our matrices. But the thing is, for normally we have the numbers 2 times 3 and equals to 3 times 2. But this one is not applicable on our matrices. Because for matrix A multiplied B is not equals to matrix B multiplied A, especially when your A and B are different size. Okay, for example, if your A, let's say your A is size 1 times 3 and your B is 3 times 1. So when I multiply A multiplied B, my size actually C is 1 times 1. But when I use my B, 3 times 1 multiplied A is 1 times 3, my output D is 3 times 3. Definitely from here you can see that is the size of these two matrices already different. So it's impossible the answer will be the same. So means that you cannot interchange the A multiplied B and B multiplied A. But for the thing is the cumulative times, if you want to multiply A multiplied B first, and then you use your AB multiplied C, or you multiply BC first, then you multiply with A, doesn't matter. As long as don't change the sequence, okay? And if you want to have a cumulative, so A times B, A times C, so this one is still applicable. And then this one, okay, so if you notice that, okay, if your A is in front and your A is at the back, they are not bringing the same thing. This one is BA and CA. And we already know that is BA is not equals to AB. So don't, if the question is asking for A multiplied B plus C, don't change your A to the back. Okay, you are not allowed to because they are not interchangeable. Okay, and then if you have a scalar, okay, scalar or a constant, so you can be putting it at anywhere, doesn't matter, because a scalar is not going to affect anything. Let's say if you have a AB equals to D, so that means you just replace your AB with a D, and then if you notice here, this is AB, so it should be DC. You cannot change as CD. Okay, if you have a CAB, so this is AB, so it's a CD, and so on. So that means for the multiplication of the matrix, you need to be very concerned about the arrangement of your matrix. Okay, you cannot simply put the multiply. Okay, and then we go for something new. It's called transpose of a matrix. Transpose of a matrix means that you want to transposing a matrix is interchanging the element row and column. So means that when you have a 4 row and 3 column, so when you have a transpose, so means that your size is already different. You become 3 row and 4 column. And if you notice, this is my first column. This is my first row. It will become my first column. So my second row is become my second column. Okay, so that means you are only interchanging the element of the row and the column. If you have transpose a matrix, and then you transpose it again, so you will get back a original. Okay, so that means from a row, you change it to become a column change back to a row, so you are back to the normal. And then let's say if you see this is a plus minus, okay, so if you want to plus minus, then transpose, or you want to transfer first and then sum later also can. But multiplication is not applicable. If you have an ABT, you multiply and then transpose, it's not as ATBT. It's a BTAT. This one, they already changed the sequence. Okay? And then for the scalar, doesn't matter because scalar is not going to affect. So because scalar is 1 by 1, so how you rearrange also will be the same. Okay? And then for example, now we look at the example 1. A is 2 by 2, B is 2 by 2. Find A and B such that AB equals to BA. So after that, ask you to find 3A minus 2B. So first thing, I let my AB equals to BA. So I just write thing here. Then I multiply. Okay, this one, it depends on you. whether you want to multiply everything or you just like me, I only multiply certain of the number because I want to cut my things short. Okay, if you don't want, you still can multiply 3 times, okay, this one is a 3a plus 6 actually equals to a, and then this one is a 3b plus 10 equals to, okay, sorry, this one will become 3a plus 4b, and then this one is 2b, sorry, 2a plus b, and then you do this down. But since if you see, notice that is only the second row give me the quickest answer, so then I do the comparison. 4a plus 3 I compare with my 29, and 4b plus 5 I compare with my 11, so I get my value of my b. Okay, then after that I substitute back into my a and b. Then after that, as I said, for the scalar, so 3 is belongs to everyone, so you need to multiply everyone inside, and then this one also multiply everyone, and then you minus. So for example, this is 3 times 3 is 9. 9 minus, okay, minus 2 times here is 13. Actually, this one should be negative 4. And then this one is a 12. Okay, 12 minus 6 is 6. Okay, after that, this one is a 6 minus 3. So it's 3. And then the last one is 3 minus 10 is minus 7. So that's one, there is only this one is get it wrong. Okay, so then we have the answer over here. And then we look at the second example. If you have an a 3 by 3, show that a squared equals to negative a plus 2i, and I is the 3 by 3 identity. Still remember, identity is the diagonal all are 1, the rest are 0 for the 3 by 3. If you have for the identity for I2, means that you have 1, 1, 0, 0. So what we do is we just get our a square. So how to get the first element, the first row, and multiply with my first column. The first element multiplied with first element, and then second element multiplied with second element, and then the third one, and then sum them up. Okay, so after that, then I get for my negative a plus 2i. Remember, identity is this one is for everyone, and then you sum everything. Since both of them are equal, so means that this one is valid. Okay, and then now, given that you want to multiply these two matrices, and then you need to find the value of x. Okay, now, so what we can do is, okay, you can multiply everyone and compare, or we want to cut our life short, that is, we just use here the first one, sorry, the second column, second row multiplied with my third column. Okay, so I will get this value. So what I do is 1 multiply 1 plus 5 multiply 2 plus x multiply 8 equals to 59. So I'm going to have my 8x equals to 59 minus 10 minus 1. So I'm going to have my 48. So my x is 6. Okay, so actually you can check it by multiply with others. So you should be getting. So if you want to check, so you can check this one with this one, then you can get. Okay, okay. So now the same thing. We want to solve for x. So where is my x? My x is here. So I only interested here. So means that is I have my 25 minus 3x. Okay, 25 minus 3x equals to this value at this location. So my 3x actually is 25 minus 10, correct? Sorry, minus 15. 25 minus 15. So my x actually is 10 over 3. Okay, so then this is how we want, excuse me, how we want to get our answer for the X for the shorter way. But if you want to expand everything, it's also can. Okay, so this one is also the same. So for the variable X and Y, so you just multiply and then you do the comparison. And so do this question. Okay, now for this one, find the matrix C multiplied B minus A. So for this question, it is advisable to use to find B minus A first. After that, we multiply with C. Okay, so B minus A. So I have a 2 minus 1, 1 minus 2, and then 3 minus 2, and then the last one is 2 minus 3. Okay, so then after that, this is my B minus A. So equals to 1, negative 1, 1, negative 1. And I need to multiply with C. So that means my C need to be in front. Okay, so my C must be here. 1, 3, 3, 1. So as usual, this one multiplied 1 times 1 is 1 plus 3. And then negative 1 minus 3. 3 plus 1, and then negative 3 minus 1. So finally, I have a 4, negative 4, negative 4, and 4. So that is my C multiplied B minus A. You can't put your C over here. Okay, you can only multiply your A is in front. Okay. Okay, then you can do for the number 2 and number 3. Okay, so find the matrix X from the matrix equation, this one. Okay, first thing, we already learned from the beginning of this video that is, if you want to minus or subtract or sum, that is all must be the same size. Although the question didn't say your matrix is size what, but it's understandable that is your X must be a 2 by 2 because this is 2 by 2, this is 2 by 2. So means that you're going to have 2, 5, 1, 0 minus 3 a matrix A, B, C, D. This is one way equals to negative 2, 2, 4, 6. You can do so. Or the other way, what we can do is we just use the algebraic manipulation. That means I shifted this one to the other side. My 3x equals to my 2, 5, 1, 0 minus my this matrix 7, 2, 4, 6. And then I subtract first. 2 minus 7 is 9. So 1 minus 4 is minus 3. 5 minus 2 is 3. And then 0 minus 9. 0 minus 6 is minus 6. And then this is my matrix 3x. And then what is my x is 1 over 3 of this one divided by 3. And remember, means that you need to multiply every element with 1 over 3. So your final answer is 3, 1, negative 1, negative 2. So this is your matrix X. Okay, so this one will be, okay, so now find the matrix B such that A squared equals to 2A plus B plus 3B. So we're doing the same thing. We just let our B equals to A squared minus 2A, and then you substitute the value of A, then you multiply, and then you get the answer. Okay, compute the following operation for the matrices following. Okay, so what is AT? Transpose. So now row become my column 1, 2, 3, and 1, 2, negative 1. That's all. Okay, and then if you want to have a BT, so it's the same because this one is after you transpose also getting the same value. So just copy back what people ask, then we just give it. And then for the other 4, then we will do it in the class. Okay, so state the order of each matrix, then identify the position of the circle element in each matrix. So this one, you have 3 rows and 3 columns, so it's 3 times 3. This one, you have 3 rows and 2 columns, so it's 3 times 2. Okay, and then let's say this one is 4 times 1, and then this one is 1 times 4. Okay, the element the position of this element is on the first row and second column. So we can just name it, just simply name this one is an A2 and is a first row 1, 2. And then this one is the also the same, although the size is different, but the thing is still the same as first row, second element. And then this one is the third row and first element. And then this one is the first row and first element. Okay, the ABCD is I just name it only. Okay, so thank you. See you in next video.